Done. Hit record. Okay, hey everybody, this is Don, and we are in Predict 411 for summer class of 2017, June 28th. So this is summer of 2017. And Predict 411, and this is the Moneyball OLS regression office hours. And so I thought we would just go through some questions, and maybe I'll try to touch on some topics. How about that? So before we get started, does anybody have any questions, comments, thoughts? I had a couple of questions before the recording, and I'll address those in a moment. But anybody else? We got Adam Phillips. What do you look like a guy with a question? Talk to me, Adam. He's being quiet here. Okay. Oh, he's texting me. Okay, let's see what Adam has to say. I'm going to call you guys out. No questions. Sorry. That's okay, Adam. I'm trying to draw you guys out of your shell. Geetha, that's an interesting name. So you're also seem like a person with a question. Oh, he's got a baby, so he's on mute. That's right. Okay. Geetha, do you have a question? No. Okay. Well, hey, I tried to draw you guys out of your shell. So, okay, well, we'll start with Bruce Pham had some questions just before I hit the record button, and I'll repeat these things. The first question that Bruce had was, just a sec, I'm going to try to share my screen in a minute. Okay, just a sec. Just going to. Okay, so let me share my screen. I'm sorry about the delay. Share screen. Oh, chat window here. Oh, Vicki has a question. Vicki, ask your question.
My question, can you hear me okay?
I certainly can.
Great. My question has to do with the Angus software because I've sent requests to them for the academic license like multiple times, and I haven't heard anything back. Yet I saw that in some of the assignments, it recommended that we use that if it was available. So, but it also recommended that there was other software packages that we could use, like something like Weka or whatever. Mm-hmm. And so I was wondering if you could give us some pointers on the other tools so we can look into those if we don't hear back about the Angus software.
Anyone you want, you can use. I mean, you have to use SAS because the course is taught in SAS. Anything that you do, if you use a Magic 8-Ball and you get good answers, then you can use it also. Everything you try will be valuable for you because, like, for example, I always recommend R because the neat thing about this is after you get done doing the Moneyball problem, you go, wow, SAS is really good at certain things. And then you try it in R and you realize that, R is better at SAS at certain things and really stinks at certain things. So you start learning the strengths and weaknesses of various languages. Salford Systems is a great one. Now, did you see, can you guys see my screen? I didn't hit share yet. Let me share my screen. Did you see that in the announcements, I did contact Angus, and they said, update on Angus software. Did you see this announcement here, Vicki?
Yes, I did, and I actually specifically used that link. And then
still didn't get it.
And I didn't get anything back, and so then I emailed this Leah Litvinoff person directly, and I didn't hear anything back there either. So my question is that, what would be an equivalent of what the Angus software does?
Well, the nearest equivalent you're going to have might be SAS Enterprise Miner. Only SAS Enterprise Miner is a lot more robust than Angus. I would say that in the pecking order, Enterprise Miner is like a 10. And this is not because I'm a shill for SAS. I'm a former SAS employee. It really is a nice tool, but it's very expensive. So you may not get this everywhere. So Angus is probably maybe a 6 or a 7. And I'm not ripping on Angus. It's just, it doesn't do as much as SAS, but it's also a fraction of the cost. And it also has some niche uses, like in the banking world. A lot of people in banking will choose Angos over for credit scoring and stuff. For even if they had Enterprise Miner, they'll still use Angus. So maybe in some applications, Angus is even preferred over Enterprise Miner. That's why I recommend it. But for the most part, I would say Enterprise Miner, and then Angus is very good. Salford Systems has a very nice decision tree interface. Somebody said it's very dated, but you know what? It's real simple. You know, simple is just because it's old doesn't mean it's bad. So those are some things to try. Definitely do R. I would say R would be my first choice in your shoes as another language. But what I recommend for everybody here, dive into something. I don't care what it is. After you use SAS, go learn Enterprise Miner. Go try R. Try whatever. Okay, you're going to get bonus points for it. Then you're like, okay, I know how to do something in Enterprise Miner. It's really simple. Then you rake in some nice bonus points. Then the next homework assignment rolls around. You do it again. You get more bonus points, but then throw another language on top of it. Then you got SAS. Then you did Enterprise Miner. Then you did it in R. Then you did it in Python. And by the time homework number 3 rolls around, you got so many bonus points. You know, you could do whatever you want on the final assignment. I had people, writing whatever you want. I mean, there's a lot of flexibility when you have some bonus points as a cushion. So, does that answer your question at all, Vicki?
It does. It does. Yeah, it gives me some other options, and I'll definitely go the R route because I'm much more comfortable with that than SAS anyway. So, okay, great.
Great. Well, definitely, you got to do SAS. You understand you got to do SAS though, right?
Yeah, I know. If I wanted to wait one more term, I could have done it in R. That's what.
Yeah, well, you know what's going to happen. I'll tell you though. Wait a second. Leah from Angus told me that they received many and so they were accumulating the requests before they get the licenses. Okay. Yeah, but you know what? I hear this every single class. Everybody's like, "Oh, I hate SAS. I love R." And by the time you walk out of here, you're gonna be changed. I promise you. You're gonna love SAS.
Yeah.
Well, one of us has taught this class like 4 times, and one of us hasn't. So trust me on this one. Okay?
I believe you. I believe you.
Okay, so let's talk about Bruce Pham's question here, and he was asking how can you use bucketing if when you put things into buckets. How can you handle that? Use that to handle missing values because he had some issues on the quiz for that. And here's a best example. Let's say that we have grade, test scores, and let's say that 90 to 100 is an A, and 80 to 89 is a B, and 70 to 79 is a C. Or you get the gist, right? So. And then like 60 to whatever is a D. So let's say that some students get like this, the first guy got a 95, and then the next person got an 87, and 40, that person didn't study, and I don't know, 77, and I don't know, 89, whatever. So these are the things. And then, this guy has a missing, okay? And then this one maybe has a, 92. Okay. And 100. There you go. Okay. So, go ahead. Is that a question? Okay. Just thought I heard a person in the background. So the question is, how can I turn this into, if we put these into buckets, I could just say, okay, the A bucket, this guy gives an A because he got a 95, and this guy got a B, right? And this guy got a 40, so he got an F. And this person got a C because they got in their 70s, and this guy got a B, and this guy was missing, okay? And then we also can do this guy is an A and another A. Okay, so what do we do with this missing guy? So how can you handle bucketing as a way of handling missing values? Well, you could do lots of things. One thing I could do is I could say, well, the middle, A, B, C, D, F. I could say if it's unknown, like this person here, If it's unknown, I might say that if it's unknown, you get an F. Okay, that's one thing I could do. I could put it in the most popular grade. I could say, well, the most popular grade is an A, so if I don't know, you got an A. Well, I'm not going to do that. That would be a bad choice. But sometimes you could do that in a situation where it's not like a grade where you can't reward somebody for not handing in the homework. But you get the gist. The most popular grade here is an A. Then I could also do something like C, of course, was the middle of the road. I could say that if you didn't hand it in, you get an F. That's most likely. That would be a business rule approach where you say you don't hand it in, you get an F. You could also do something like give it its own category, X. A, B. So when these things go into a predictive model, you get A, B, C, D, and F, and then X means it's not. It's not. It's its own category. So these are ways you can handle or treat a missing value. You just treat it as something and you shove it into a bucket. You treat it as a value. So Bruce, does that answer your question, or did I totally confuse you?
No, that makes sense. It works. Thanks, Don.
Okay, great. Okay, perfect. So Bruce also had some questions about transformation. So I thought maybe I would just go through the Moneyball problem real quick and do a bad model. I mean, I'm not going to try to make it the best model, but I thought I would do that. And also I had questions last quarter when I taught this class. Some students had asked me too late into the quarter to do anything about it, but if I wanted to write code and use SAS code, how would I do a holdout sample? So I said, well, I'll walk through a way to do that. And so I'm going to put it in tonight's lecture. So let's talk about that. Let's see. Don't save. We don't need that. So you guys can see my screen, right?
Yes.
Yep.
And okay, great. Don't worry about taking notes. I'm going to post this. When I post the recording tomorrow, I will post this code with it, okay? So you guys are perfectly fine. So what I'm going to do here is actually I'm going to get rid of that because I don't want you to see it yet. Because I'm going to add some stuff later, and I don't want to confuse you by putting it in there now. Okay, so all I'm going to do is I'm just going to start off by defining where my library is. Now, this stuff is on my local hard drive, so your paths and stuff will be different. But all I'm essentially doing is I'm creating a libname statement here, and I'm going to, this is where my Moneyball data is. So this is nothing that you haven't seen before. So I'm just going to set up my environment variables, and then the first thing I always do in the real world is I take my data set. Let's print the data set for the heck of it, just for fun. I'll teach you guys some good technique as we go. So I'm using what's called a SAS macro variable because every time SAS sees ampersand in file dot, whenever he sees that, he goes, well, that's a macro variable. And he runs up here and he looks, oh, look at that. That's a macro variable called in file. And then he says, okay, that's Moneyball. That's my data set. So every time he sees Moneyball or in file, he shoves the Moneyball file in there. So I give you guys bonus points for using macros because they're very powerful and useful tools. So if you don't know about macros, that's just something to, that's what's going on there. So I'm just going to run the first bit of code here, and we're going to print the first 10 records. So there they are. And you can see I've got some missing values here, et cetera, and I'm sure we have some outliers. We'll take a look at that in a minute. Now, the first thing that I always do when I am working with a data set is I make a copy of it. Why? Because if I don't make a copy, I might accidentally screw my data set up. So I like to have a data set that, my original data set, when you pull it out of the database, I have overwritten, you pull it out and it takes like 5 hours to get it out of the database, and then all of a sudden, you overwrite the darn thing and you're like, oh, geez, that was a nightmare. Now you got to go back and tell your boss, hey, I'm late, going to be late on the model because I destroyed my data. it's not a pleasant conversation. So I'm going to make a copy of this guy. And so data, set, and run. That's it. I'm just this going to read each line one by one by one, and he's going to dump them into this guy here. And Vicki, this is why you're going to like SAS over R, because SAS has data steps and R does not. I'm always amazed that the people out there in the R community, they think, well, gosh, we need another neural network, because 75 of them isn't enough. But I don't know why the people in the R community don't create a data step in the R language, because if they did, I think they would put SAS out of business. So that's what I'm waiting for, and then I'll jump on the R bandwagon. So anyways, let's make a copy of the data set, and let's just print the first 10 records here. And you can see it's the same, these are the number of wins, etc. Okay. So the first thing that I'm going to do is let's look for, I like to explore the data. And you can do this with really two different SAS procedures. And there's a lot you can do this in other languages like R and Python. There's all sorts of stuff, and they're essentially pretty useful. I'm going to run proc univariate, and I'm just going to say, hey, can you please look at our target variable, the number of wins that we have. So let's just take a quick look at that. And this is kind of neat. So you can see that if I use proc univariate, it will tell me that I've got 2,276 records. The average is 80.7 wins in a season. Let's see, I think they have min and max or something in here too. Okay, the maximum is 146 wins. The minimum is 0 wins. The median is 82. So this is kind of the distribution of this guy. And here's a nice graph of it as well. So, okay, so this is one way of quickly exploring the data. Proc univariate, I kind of like it for a quick way to get a nice graph of it, but I think that usually what I use is proc means, because it can just give me some information real quick and dirty. In this case, proc means, and I'm going to do, N is just going to tell me how many records there are. N miss is going to tell me how many missing guys there are. So if there's missing, we got to fix them. Then mean is just the average variable. Median is the middle. Min is the most, or, the least amount. Max is the maximum amount. And this is the 5% cutoff and the 95% cutoff. And Bruce was asking me about ways of handling outliers. I'm a huge fan of capping the values. I also like log transforms and a few other ones, but my go-to one at first is literally capping. If I could get away with it, it's a simple way to deal with an outlier, okay? And it's effective. So let's just run this guy real fast. And if I run it, you can see I've got every single variable, and some of these guys have a lot of missing values, okay? And I can also see that I have some, real outliers here. Let's say like the number of wins, 146 wins, even though the 95th percentile is 104. So there's a big difference there. And the reason why people are saying, well, how can you have 146 wins in a season? Well, the reason why is because this is real data, but what I did was the data set that I got was normalized, because back in like 1892, they might play like 3 games in a year. So this data set has been normalized so that team from 1892, how would they have done had they played a 162 game season? Well, back then you would have like a bunch of guys might have played the Girl Scouts or something like that, and a bunch of preschoolers or something, and so they racked up some huge numbers. And then you say, well, how can you hit 11,000 home runs in a season? Well, the reason why you do that is because you play one game against a preschool, and you rack up a bunch of things, and then you normalize it to to 162 games. So that's kind of why we have these outliers. So I would look around here for outliers. Like, again, let's look at some of these guys, like the number of hits in a season, 2,500. Where's the 95th percentile is that? So where I look for the outliers is I usually go for the maximum versus the 95th percentile, and I'll look at the minimum versus the 5th percentile. So that's kind of where I start off. Now I saw that there was a chat. I can't see the chat window when my screen is being shared. Can someone tell me what the chat window question is?
Sorry, Don, that was me. I was just curious, does that same methodology apply to the 0-win record as well?
Yes.
Did the team really lose all the games?
Well, yeah, that was probably a team from, like, again, 1892 who played 2 games in a season and lost both.
Gotcha.
So
thanks.
And then you scale it up to 162. They still lost that many. So that's what I love about this data set. Is not only that's why there's so many missing values too, because they didn't collect a lot of statistics in the early years, like hit by pitch and caught stealing. They just didn't collect that stuff. And also the number of, like, back in the good old days, the number of strikes, you needed 5 strikes and 9 balls, to get on first base or to strike them out. So the statistics over time have changed. They become less. There's no consistency. So this is real world data that fights back. So anyways, so let's do this. Let's pick like 3 variables and with some missing values and everything else, and some hellacious outliers, and let's see what we can do with them. Like, I don't know, let's see, number missing. Let's go with something like, okay, the strikeouts. Let's use this one because there's some missing values. Okay, so let's use this guy for sure. So we're going to use the team batting strikeouts right here. So this is how many times you strike out. So we're going to keep that one. Okay. What else do you guys want to use? I'm going to let everybody, we'll choose like 4 of these things. Anybody, come on, give me something, somebody. Vicki, you like R. Give me a something here.
How about how about the double plays?
Oh, double plays. Okay, fair enough. Team fielding double plays. Okay, let's do that one. I saw somebody on the chat window. Let's.
They said caught stealing.
Caught stealing. Okay, we've got some real weird stuff in here. Okay, caught stealing. Let's do that one. And let's try to make our model not be totally horrible. So let's also maybe put like, how about the, I don't know, how about the number of base hits? Let's at least put that one in, the base hits. Okay. So there we go. Well, we should probably put a pitching one in there too, right? How about the number of times you walk somebody? Okay, there we go. So that's enough. That's enough variables. So I've got hitting, how many hits you got, base running, batting, fielding, and pitching. So I think I got everything, didn't I? Oh, I got 2 batting ones here, didn't I? Let's put them together. There we go. So how many hits, how many times you strike out, how many times you got caught stealing, how many times you got a double play, and how many times you walked, or your pitcher gave up a walk. So there we go. That's what we're going to work with. Okay. So let's see what we got to do here. Oh, we have to do one other thing. We got to keep, obviously, our target. Okay. And let's keep that guy. So if we look at this now, you can see it's a much smaller data set. So this is kind of one of the things I do is I first like to, prune down the data set. Now in this particular case, I threw away a lot of stuff and I haven't done any exploration, but a lot of times you'll get a data set with like 1,000 variables in it. If you can start throwing some of that stuff out, immediately, you're going to save yourself a lot of headaches. People say, well, they're always afraid of throwing away the baby with the bathwater. And what I always say is, look, this bathtub's got lots of babies in it, okay? So if you throw away some of the babies with the bathwater, you're still going to end up with a good model. So that's kind of my rule here is I like to just, if I know for sure something's not going to be predictive, I don't keep it in the data set. So let's take another quick look here at the our friend the proc means. Let's see what we get here. Okay, so we've got some missing values. Step number one in solving this problem or any problem, you got to fix the missing values. Okay, so there's lots of ways we can fix missing values. So we have here the team strikeouts, team batting strikeouts. So let's do something with that. So if it's missing, so the first thing is whenever you fix a missing value, you don't just overwrite the old guy, okay? That's not what you do. What you want to do is, because if somebody later on sees your variable, he's going to say, well, gosh, team batting strikeouts, I read that in the database, and I expect it to look a certain way. It's going to have missing values, and it's going to be in a certain range, and blah, blah, blah. And here you are monkeying around with it, and you've taken a log transform or something. And he's like, why is this thing, got this weird distribution? Well, because you took a log transform of it. Well, so anytime you monkey around with the data, you got to give it a new name and use that one instead. So we're going to have this. Incidentally, does that make sense what I just said, or did I totally confuse everybody? I'm hearing silence. Somebody help me out here.
No, it makes sense.
Makes sense? Okay.
Totally makes sense.
The first thing I'm going to do, okay, great. The first thing I'm going to do is I'm going to create a variable called imputed team strikeout. Okay? So I've got this imputed team strikeouts, and I'm just going to copy this guy into there. And guess what? I'm going to save that one instead. So imputed. So the imputed strikeouts. We're going to keep that guy instead. And now what we're going to do is we're going to say if missing, so if this guy is missing, then how about if we make it equal to something? Okay, we could. Now there's lots of really sophisticated ways of filling in a missing value. The two best ways to fill in a missing value are the best way is to use a decision tree. Okay? Unfortunately, using a decision tree, unless you're using a tool like Enterprise Miner, can be a very cumbersome and slow process. You don't want to do that unless it's a really important variable or you have a tool that does it for you, okay? How a decision tree works is this way. Okay, let me tell you the second best way. The second best way is to use the average. In this case, the average number of strikeouts is 735. That's the second best way to do it, but it's the easiest way by far. And just because it's easy doesn't mean it's bad. Many times you're going to get a really good model just by using the average, okay? So what we're going to do is we can fill this in with, I could use the mean or the median, so maybe 735 or 750, or maybe we choose something in the middle like 740 or 742. That's probably in the middle there, right?
Hey, Don?
Yes, sir.
I have a question on using a decision tree. It should be fairly quick. If I were to use a decision tree to come up with a number, I guess whenever that particular variable comes up in the tree, at the first whatever level it is that the number I use?
Mm-hmm.
For the
okay.
Does my question make sense?
Okay, so you're asking. So I'll tell you how the decision tree works in a second. But this is how I'll solve one of these using a decision tree type of approach. How about that?
That works. Thanks.
That works? Okay, great. So anyways, so I'm just gonna, this first one, we're gonna fix this guy using a just some number that we've decided on that's, the average is 735 and the median is 750. So I'm just going to split the difference and say 742. And you don't have to sit there and use a lot of advanced math on this. You can just use a simple, logic. This is street brawl analytics. And my thought is this: if your model makes sense and it makes money, it's right. Okay. So does it make sense to split the difference? Well, doesn't cause any red flags to go up. So I probably wouldn't worry so much about that. So we also might want to create a flag variable as well. So let's do this. And then we'll do a tree in a minute. So sometimes the very fact that a value is missing is highly predictive. For example, if you go into the bank and you say, hey, I want to get a loan, and then they say, well, let's see what your debt to income ratio is. And then they look at you and they say, wow, Fred here doesn't have a debt to income ratio. So they might impute it with the average, which would be like, I don't know, 35, which means that 35% of, your debt is 35% as large as your income. Okay, that's great. But we had to guess at that because we didn't know. However, usually, if I don't know your debt to income ratio, that means that you don't have a record in the credit bureau. Well, that's not a good thing because maybe that means you changed your identification. So the very fact that you don't have a variable there is highly predictive of the fact that you're not going to pay us back. So missing data, the very fact that something is missing can be highly predictive. And it's kind of like there was a Sherlock Holmes episode where the dog doesn't bark, okay? And when the dog didn't bark, that meant that the dog, Sherlock Holmes says, well, that was missing data. And the dog didn't bark. That tells us something. And then it says that the dog knew the killer. So the guy who owned the dog was the killer. And so that's a spoiler alert for anybody who hasn't seen that one. So just letting you know. So, okay. So let's create a flag, and we'll call it M for missing. And we'll say, so we're going to say, no, we didn't fix this. However, if it was missing and we filled it in, then we'll set that to 1. So how's that sound, everyone? Does everybody just see what I've just done here?
Yes.
So I made a copy of the variable. I created a new variable and I copied it. I also created a flag variable, and I have to make these line up, otherwise it will drive me nuts. Okay, so I created a flag variable, and the flag's going to have a 1 or a 0. So then I said, okay, hey, if this guy's missing, I'm going to fill him in with an average value, and I'm also going to set that guy to 1. So let's keep that one too. So let's run this real fast, and then I'll show you how we might do this with a a decision tree. So let's see. Now we should theoretically have, look at this. The imputed team batting strikeouts doesn't have any missing values. Okay. So we'll handle the outliers in just a minute. I want to first get rid of all the missing values. Okay. So let's do this. Okay, a decision tree works this way. Now, if I don't know, let's say, how much money you make. So if I don't know how much money you make, I could say that the average person makes $50,000 a year. So we could say, okay, if I don't know how much money a guy has, it's $50,000 a year. However, what if I wanted to do a decision tree approach? And a decision tree doesn't have to be a big, complicated decision tree with 50 levels. You can do it with just one level. You could just say, what kind of car does the guy drive? If the guy drives a Maserati, well, he probably makes a lot more money than 50,000. So you could say, okay, if the guy drives a Maserati, then I'm going to say he makes $1 million a year. If he drives a Toyota, I'm going to say he makes 100,000. If he drives a Chevy something, a Volkswagen Beetle, he makes 30,000. And if he drives a shopping cart, around in the street, he's probably makes 0, something like this. So this would be probably how a tree would work, is a simple if then else rules. So let's say we look at the double plays here. Okay, the team fielding double plays. And let's see here. Let's go back and take a look at our friend the errors. There was we had errors was one of the variables, right? It was called team fielding errors. There it is, team fielding errors. Let's put that guy back in. I'll show you what I'm going to do. Let's put him in for just a little bit. Team fielding errors. So this is how many mistakes you made. Like when I was in Little League as a kid, and the ball would come at me, I would be afraid and I would run. So I made a lot of errors. Incidentally, I didn't have a very long career in Little League, but that ball comes at you pretty fast. So let's say these guys, let's say I'm playing for this team. Let's say this is the Cleveland Indians. So actually, I can't really make that joke because we're doing pretty good this year, but let's pretend that we stink. Okay, so the errors of these guys are what? The average is 246, and the median is 159. Okay, great. So we're going to say this. Watch this, everyone. So we want to fill in the double plays, right? The double plays are good, but some of them are missing. So let's do this. Double plays, imputed. So we make a copy of it. And that's the first thing you always do, is make a copy of it. And then we create the flag variable. And watch what I do here. I'm going to do a decision tree approach. And this means we didn't fix it. And if missing then do end. Okay, watch this, everybody. Okay, so if it's missing, what are we going to do? Well, let's go back over here in errors. Let's say this. If you make more errors than the average, you're probably not very good, okay? So I would say that you probably make not a lot of double plays. So let's say we do, if you make more than the average number of, so the average is 159. So we're going to say this. If the team fielding errors is greater than 159, that means you made a lot of mistakes. Then what we'll do is we're going to say that, oh, I don't know. Then what do we want to do here? If you made a lot of mistakes, you probably don't make a lot of double plays, right? So let's say that if you make, how many double plays? The mean is 146 and the median is 149. The minimum is 52 and the maximum is 228. And the 5th percentile is 98 and the 95th is, okay, so let's say if you get more double plays than the average, more errors, you're bad. So you don't get a lot of double plays. So we'll say that you only get 98 double plays. 98. And otherwise, you're really good. So we're going to say that double plays, 186. How's that? Does anybody see what I just did, or did I totally lose everybody?
That makes sense.
I'm hearing.
Makes sense.
It makes sense.
So, oh, great, because I was afraid I lost everybody, and I was getting worried. Okay. I probably haven't. Please don't be afraid to stop me. Okay. So now we got to make sure that our double plays, where are they? Here's our double plays. So we have to make and save this guy instead. Imputed that.
Can I stop you?
Now, do I have a question?
Yeah. So
Okay, what's the question?
I know you're doing a simple example, but can you summarize how we would expand that? Because I understand what you're doing, but you have, if the errors are greater than 159, then they got a 98. If they're less than or equal to, then they get a 186. So what we're potentially doing is comparing a team that got 160 errors, they get a 98. The other team had 158 errors, and they get double.
Right.
So
right.
I guess how would you?
Yeah, if you wanted to expand this, you might want to do a quick, histogram of this, and then maybe, I'm doing this quick and dirty. A real decision tree, you might, now this is not even really a decision tree. It's kind of a decision tree in that we're using some other variables and some if then else logic. Now, if you really want to get crazy, you would dump this data set into, let's say, R. R has some really nice decision trees, or Angus or Salford Systems, and you would build a decision tree, and you would have as your target variable the double plays. And so you would build a real quick model using a decision tree in R. You would say, okay, predict how many double plays. And then the decision tree there might have like 3 or 4 levels deep, and they would have, and it would break this thing down into much more sophisticated rules. Now, if you do something like that, please point it out and you can get some bonus points. I would not advise, given that you have 3 weeks on this project, to do this to every single variable. Do it to one variable and get the feel for how to do it. Find an important variable that has some missing values and take it through, something a little bit more rigorous than you see here. But the idea is that I look at other variables like this, and I say, okay, this guy right here is might be a good indicator of whether or not the person gets, how many double plays they have. And you're right, this is almost double. So maybe we say, what's the middle of the road here? The double plays. The average is 149. So okay, let's make it 149 plus or minus. So 149 will make one guy 140, 140, and the other guy 160. How about that? That might be a little bit less draconian. How does that sound? Nothing? Okay. Did I lose everyone? I'm on a hotel phone here. Is this, can everyone hear me?
Yeah.
Yep. Still with you.
Okay, great. Okay, great. Okay, so we got that guy there. Let's move these two guys, and we'll handle outliers in a minute, okay? And can I get a volunteer so that every time somebody asks a question, I can't, I can see somebody on the chat window, but I don't know what they asked. Can someone read the questions on the chat window?
Yeah.
Hey, Don. I was just saying for these decision trees that every time you have a split, you have to build out a new if statement, and they become nested if you have more than one depth of your tree.
Exactly. This will be if then else's, and these things might go kind of deep. That's another reason why people don't use them as often, because a lot of software will give you a nice tree and then you got to type in a bunch of if then else's. What I love about SAS Enterprise Miner is that there's a node in there called the Impute node, and if you watch some of the videos that I have posted, I actually show them, the SAS actually does write the code for you, which is kind of nice. And incidentally, for my R fans in the audience, I'm not ripping on R. R is a really great language, and it's also free, which you can buy a lot of inconvenience for free. Free. You're willing to put up with a lot for a nice free program. Okay. So, anyways, take a watch in some of those things, but yeah, these things can get pretty nested if you you do that. Let's handle the caught stealing. Let's just fill that one in with the median. How about that? So if or you guys get the gist here, we're not even going to create a flag. Well, let's create the flag. What the heck? I'm not going to tell you guys to use good technique and then turn around and then not do it. Okay, imputed team, and voila. And gotta make this line up. Set it to 0 means we didn't impute it, and then we come over here and if missing, then do, and okay, we'll just set this guy equal to something reasonable. Caught stealing. If it's caught stealing, we'll make it 49, and then that's the median. How about that? Okay, there we go, 49. So now we've got the caught stealing has been handled. So imputed, and there we go. So we've got that one. So let's just see about hits. Oops, we don't need that one. So hits and base on balls. I don't think either one of those is missing. Hits doesn't have anything missing, and base on balls, nothing. Okay, so let's just also handle outliers now. My favorite or preferred approach for outliers is to simply cap them. So if they're over a certain value, I just pull them in. It works. Okay. In some cases, I'll do things like a logarithm. If I've got a distribution, let me pull up, trying to think of a way I could draw something easily. Let me see. Whoops. I'm going to poke around here and see if I can find like a drawing program of some kind. Just a moment. Well, heck, how about if I just use paint? Okay, let's share my screen. Here's paint. Okay, if I have a variable like I was working on something at Sprint recently, and we got something with how many gigabytes of memory people use, or not gigabytes, kilobytes, and there's a whole bunch of people up here, and then you get some people that are way, out here. And you don't want to just cap them at this because these guys are clearly, it's not like we're dealing with a baseball season and somebody's got 146 wins and it just doesn't make sense. But most of the people are, like, almost everybody was between 40 wins and 104. And then you get a couple of stragglers. That's when you pull them in. But when you get something like this, some distribution, and then you get these guys at 0, and these people are out here in terabyte land, okay, that might not be really good. So maybe this is a good time for the log transform, ln or log log. One is based on log is based on the number 10, and this guy here is based on the number 2.71828 or whatever. I don't know what the number is off the top of my head, but these are two logarithms, and they'll pull this thing into even if this number out here is like a billion, it's going to pull it into a number 9. Pulls a billion, gets pulled into like the number 9. So this can really squish that stuff in if you do have some outliers. So I would say my first choice is if I can figure out a way to cap it, I will. And if I have something that is capping doesn't make sense, I think log transform, either ln or log, depending on the scale, would be my second choice. Does that make sense to you at all? Or who was asking that question? Was it Bruce? Are you guys still with me?
that was Don. That was me.
Okay. So let's do that. Oh, go ahead.
If I log or natural log the predictor, do you have to do that to the response variable too?
No, you could do that. You can do that to your response variable if you want. In this case, I don't think we have to do that in this case. I don't think we have any outliers that are that obscene. But you could do that. I would probably just cap the variable at that point. Or if it's so insanely wrong, outlier, like you say, like predicting how much money somebody makes, and everybody's between $20,000 a year and $120,000, and then you get Bill Gates and he's making $100 billion. Well, you're like, you know what? It may not make sense to cap Bill Gates at 100,000. Maybe you just throw him out of the data set and don't even use him. But I don't think you could conceivably take a log transform, but I don't know. I think I would probably just either cap it or, and that's only in a case where it's so pathologically out of, orders and orders of magnitude off of everybody else. But that's about it. I don't usually monkey around often with my target variable. But that's, again, my personal technique. Doesn't mean it's the right. It's just that's what I do. Over years, you just sort of get in the habit of doing it a certain way. Let's just real quickly cap some of these things. And then, so you'll notice that a lot of what I do here is spent on playing around with the data. Just we've been here for almost an hour, and almost everything we've done has been monkeying around with the data, and that's what it should be. Now, I'm not going to cap everything because it's going to take, I want to get into some other things, but let's pull in some of these guys. Let's see. We got let's see. Caught stealing, the maximum is 200, but then this guy's at the 95th percentile. What else do we have? Double plays. Home runs. Let's see. We have no hits. There's a big difference in hits. So let's say that we're going to pull in the hits so that it can't be greater than the 96th percentile, okay? And it can't be less than the 5th percentile, and it can't be more than the 95th. How about that? So let's do that really quick. So we'll say that the capped hitting variable, So hits is right here, is equal to the hits. Now we're going to say if this guy is greater than 1696, then he equals 1696. And if he's less than 1280,
Do you normally use percentiles, or I remember a different class we had like I forget what it's called, a bow tie, or somewhere we use 20% or 10%. Do you typically use percentiles, or do you use any other methods for the cap?
The short answer is, if it makes sense, you can do it. This is just the first thing I thought of off the top of my head. I would probably explore the data and maybe graph it and see kind of what makes sense. But that's about what I would be doing. Is I'm just doing that. It makes sense to me off the top of my head without thinking of anything else. I would probably just do the percentiles. That's a safe way to go. But you could do anything. If you can think of a way to do it and it sort of makes sense, give it a try. If it gives you good results, then it's right. There's literally a lot of this stuff is just trial and error, and there really isn't any one right way to do any of these things. I'm just giving you things that I've picked up over 20 years of doing this stuff. I've probably developed some really good habits and techniques and some really bad habits. Unfortunately, I don't know the difference between the two, but I'm hoping some of this stuff will rub off on you. Anything that seems to make sense, you should use it in your careers. And if you don't like it, discard it and choose something else. But this is not a bad way to go, quick and dirty. Does that make sense at all, or?
Yes, thank you.
Okay, great. So let's just build a model real fast and see what comes up here. So let's put these guys in here. And one of the neat things that we have, so we're only using these variables, and we're also going to do a stepwise selection. And one of the things that we're going to do is we're going to create a variable here called y hat. So so what I'm going to do is run the proc regression, and we're going to try to build a model with these guys in a stepwise selection. And then SAS is going to append a variable called y hat, which would be the prediction variable. So let's just do that real quick. And did I get an error or something? Uh-oh. Not found. Did I not run? I might not have. Try this again. Let's try it now. There we go. He's running. I forgot to. Okay. So my R squared is 18. That's not a real good R squared, but I would imagine my experience with this class is that most students are in the mid-20s to maybe an R squared of 40 for this data set. If you did the bingo bonus, you'll find that there's not a lot of difference between the accuracy on the holdout sample between those people. If you're sort of in the same range as everybody else, you're probably like, for example, if somebody gets a 40 and somebody gets a 25 on their R squared, I would say it's a coin flip as to who's going to perform better on the test data set. If you had a 60 as your R squared, I would say it's almost certainly you're going to get a bad score. And if you got a 5 on your R squared, you're going to get a bad score. So what you're really shooting for, and this is what I do, my experience, is I build the model about 4 or 5 times with everything, and I do a stepwise selection, and I sort of get a feel for where that adjusted R squared is. Like, okay, I want to just get where it usually is. And then if I start playing around with the data and my R squared jumps, in this case from like 30 up to like 90, I'm like, I overfit it. That's too good to be true. Or if I do something and it goes from 30 down to like 1, nope, that's I've really messed things up. So that's kind of how I do things, is I try to look for a sweet spot and hang around in there. So in this case, I know 18 is probably not all that good, but for our purposes, we're going to just keep going. You'll notice that when we print this guy, whoops. SAS put this y hat variable on the end. Now, you guys are saying, well, okay. The thing is, that's not going to be any use to you at all when you're trying to score a test data set. The reason why SAS is doing this is because we might want to do what I'm about to show you now, which is we are going to create a holdout sample to see how good our model is. So this is what we're going to do. Let's come down here, and I'm going to get a random number seed, and these 2 macro variables. Let me put them back up here. Let me run them. Okay, now what are we going to do with those guys? You'll see in 1 second. And then the other thing that I'm going to do is I am going to create up here a flag that says whether or not we should use this record as a test variable. So what will happen is RANUni with a seed value is going to create a random number between 0 and 1. So it could be 0.42 or 0.39 or 0.96, whatever. It's going to be some number in that range. And I'm saying if that number is less than 30, then this guy's going to be a 1. If it's greater than 30, it's going to be a 0. Okay. Now the next thing I'm going to do is I'm going to create a variable called y. I'm going to copy my target variable and dump them into y. So I'm making an exact copy. Then I'm saying, hey, by the way, if this test flag is 1, I want you to make my variable to be missing. Okay, what did I just do? I'll show you. Now, this is going to be confusing people, so I'm sorry, but I'll answer questions in a second here. So take a look at this. Okay, this first guy on the list. Oh, wait a minute. Forgot to do something. I got to add these guys to my keep statement, don't I? Okay, let's try one more time. Let's see, what time is it? Because 9:07. My fear is that since I'm in this hotel, my internet sometimes just shuts off for no reason. And if it does, don't go anywhere. I'll try to log back in. Okay, so anyways, you can see here that it used to be that I had this target, the number of wins the baseball team had used to have values. But remember, I set them to missing. I threw them away. But then if you look way over here, maybe I didn't. What the heck? Keep Y, keep test flag. Did I miss them? Oh, here they are. Okay. So if I'm going to use this guy for testing purposes, I got this set to 1. And even though I turned this to missing, I know that it was a 39. So I'm holding it. I'm keeping it in the background. This guy, I'm not using him as test. So he's 70. And by the way, he's 70. So that's the same thing. 86, I'm not using him for test. So there he is again. You know, here it is again. He's a 1. So I'm using this guy for testing. So I'm throwing this guy away. What happens is when I throw this guy into a proc regression, if this guy is missing, he won't use that record. So let's run this one more time. And so now I come over here, and if I print this guy, you can see that we have a value of this guy. We don't know what he is. We do know that in reality it's 39, but we didn't use it when we were building the model. So 39, and then SAS predicted this guy would have 81 wins. So now what we could do is we can calculate the error. I could come over here and I could say the error is equal to this guy minus the predicted one. Let's square it so we can make it an average, an error squared. And then I could run a proc means here. And this proc means will calculate the, let's take out the no print here. Well, so you can see that the average error squared is 202. For my training data set, it was 198, and then this guy here was 212. And then I could say, if I take the square root of that guy, that's going to give me the root mean squared error, and this would be a good indication of how well I do on the KAGLLE competition. And you can see here that these two guys perform about the same, which is a good sign. If one of these guys was really good and then the test was really bad, then that's a sign that I've overfit my model. Now, I know I have lost everybody in the class on what I just did, but so let's go back and ask questions about this. Does everybody, okay, I'm not even going to ask. I know that I've lost some people. Okay, who's lost? And let's talk about this. What did I just do? Anybody in the class? Let me get everybody here. Let's see. Brian, my TA, you're on the phone. Talk to me. Did I lose everybody?
Well, I don't know if you lost everybody. I know Bruce is good, and Adam says as long as you make sure the code is posted, he'll be fine.
Okay. Fair enough.
I think.
So. Go ahead.
Don, I had a quick question. So I guess I understand. I think the process of what you did, which was to basically carve out your data set into essentially training and testing again, right? But I guess I'm just kind of confused because aren't we only working with, we're already working with training data anyway, right?
Right. So I'm saying that in the real world, when somebody gives you a training data set, you carve out your own little test set so that you can see how well it's going to do.
I see. That makes sense.
So when your boss says, how's this thing going to do, you have a pretty darn good idea. And I was thinking about doing this, and I'm going to do it. Here's what you guys can do. If anybody wants to predict for me what they think their root mean squared error is, so whoops, let me just run this guy again. So here's a crazy, anybody want to earn some bonus points? If everyone instantly wakes up, is if you run this code and you can predict what your root mean squared error is, and then when I dump your scores into KAGLLE and KAGLLE gives a value, then you're going to say, I predict that my root mean squared is going to be this. And if you are within 0.1, so in other words, it says it's going to be a nightmare for me to grade this. This is what you're going to do. In your report, you say, I predict my root mean squared value is going to be 14, okay, or whatever. And then I'm going to post what everybody does. And then you can say, hey, Don, guess what? I was within 0.1, and you send me an email after I grade this thing. I'll give you 10 bonus points. How about that? So does that make sense, everyone, or is that did I lose everybody on the bakery on that one?
10 points. Wahoo!
10 points.
Which?
Can I see the code again? Jason, I'm going to post the code, but yes, I will post, let you see the code again.
Can
So
you show that
somebody's
output
asking me
again real quick?
Sure. Okay. So the output looks like this because I ran a proc means, and remember the test flag is 1 or a 0, right? So I'm saying proc means, and I want you to class this guy by 1 and 0, and then put the output into this file here, and I want you to give me the average of this guy and name him RMSE, and then I want you to take that guy and take the square root of him. So that's what I'm doing. And so then what he gives you is, he'll say, the average error square of everybody is 14.2. The average error square of your training data set is 14.0. And the average, I'm sorry, root mean square, the average root mean square is 14.5, whatever. So.
And it's that test data score that we would post in our report.
Or whatever you want to do. Now, I mean, yes, the answer is you're gonna say what you predict your test result is going to be.
Got it.
Just put it at the very top in a big capital letters, okay? And it's your responsibility to tell me if you made it, because I can't go through those things. Now, here's something that I like to do. When I'm done and I think I got a decent model, I will change my random number seed. I throw all of my data back in the bag and shake it up and run it again. And I see and I would expect if I have a decent model that I'm going to have something relatively similar. Yep, 14. Look at this. I got, again, similar things. If I keep shaking it up, I would expect my root mean squared error to be about the same. If it goes from 10 and then to 18 and then down to 6, whatever, that's not good. So that's kind of what I'm suggesting you do is run this a few times. Now, the last thing we're going to do, and we'll do this fast, is you got to come up with a score program to score we have a real test file that you got to score. So we're going to do data score me. Whoops. And I'm going to try to get out of here quick because I think I'm about to, Hilton Garden Inn is going to data score me, and then we're going to say set in file, and that's the Moneyball data set. Run, and then proc print data equals score me. Observations equals 10. Run. Okay. So we'll start off by just doing this real fast. Okay, this is our training data set. And then what I'm going to do is the first thing you do is we're going to copy all of our transforms. Everything we did to our training data set, we got to write in our score program. Except for the part where we do the test flag and stuff like that. But all of our fixing of the missing values and all that stuff, we do that. Then the next thing we're going to do is we get our results from our regression. And our regression results were right, where were they? Right here. Here they are. So that's where they are. So after we create all of our variables, we come down here and we say, I think it's called P target wins. And that will equal this guy plus the hits times that plus the base on balls times that plus the imputed team strikeouts times that plus the flag times this plus that. And last but not least, this guy, voila. And then, of course, we have to get rid of all this junk. And delete. Oh, go ahead. Do I have a question?
That last line, is that supposed to be a multiplication?
Yes, that is. But it's multiplying it by a negative number.
At the beginning of the row.
At the beginning of the row.
Last row. Instead of saying
last
plus
row,
M team fielding, it says times.
Yes, times.
All the way to the left.
This guy right here. All the way to the left. Oh, yes. That was a test. and who was the one who spotted that first? Because they're the ones who are going to get 75 bonus points.
That's Jason. I'll take them. I'll take them.
I'm just kidding. I was expecting you guys to all dive all over that and take credit, but you guys didn't.
No, we're honorable.
I know, boy. What fun is that? It's fun. Okay, now one other thing, guys. Let me do one quick thing. Proc means data equals score me. Okay, and I want to do number missing, a min, and a max. Run. Why am I doing this? You'll see in 1 second. The reason why is we have two things. Go ahead.
It says man.
Oh, man? No,
min and man.
Oh, max. Yeah, great. Again, another test, and you passed it. Okay. Okay. Why am I doing this? I'll just tell you why. First of all, my predicted wins. Okay, in this case, I don't have any outliers, but first of all, you check number of missing. If you have anything, this is like T-ball. Everybody gets to play. Everybody's supposed to get a score. Okay, so when you're scoring the test file, everybody gets it. Second of all, you shouldn't have any negative values or any really super high values. This is mathematics. It's not a suicide pact. So what I usually will do is when I'm done, I'll come down here and I'll say, if this thing is greater than, if it's greater than, let's say 110, then he equals 110. So I'll never let him be over 110. And then I'll say if he's less than, I don't know, 40 wins, then he equals 40 wins. Voila. Okay, so I cap this thing into something reasonable. Now, the last thing I do is, well, right here, this is our training data set. Now let's go and try this with the Moneyball test. So Moneyball test would be this. So this is a test data set now. So we got to score the test data set now. And this is the one you're going to submit to KAGLLE. So let's see what we got. So we've got a minimum of 55, a maximum of 98, and nothing is missing. Great. Now what we're going to do is we're going to print var, index, and key target win. And let's just print this thing real fast. And let's see if we can submit this thing real fast. Does anybody have any questions? So you see I've just scored the entire test guy using the test program. I'm hearing a lot of noise in the background. Has somebody got a question or something? Nothing. Hey, Brian, what talk?
Sorry, I think that was me moving my mic around.
Oh, okay. But has anybody here got any questions? Is there anything on the discussion board that I need to know about?
Bruce had to leave. He just said thanks.
Okay. Well, I'll post this stuff later. Okay, so you saw what I did. Does everybody see that I just scored the test file and now I'm going to dump it into Excel?
Yep.
Yeah, I'm following you.
Okay. Okay, so I'm just going to dump this. I just copied and I'm going to paste this guy into Excel. Let's delete this column. Delete. And then all we really need to do is save this guy. And then we're going to save it as a CSV. So let's do save as a CSV. Where is that? Right there. Nope. One comma separated variable, and we'll call this one Don1. Okay.
Can we repeat this for each of the 3 models that we create, or we just pick the best one?
Well, you could do either one. You could do as many as you want. You don't have to. If this is a pain in the neck, then don't go doing this a lot. But some people really enjoy submitting these things. But whoops, I always hate doing this. I'm never sure what I'm supposed to type. Don't save. Let's see. This will work. Don1. Let's see. Let's just see if this works. And we should have something here. There it is. Great. What I usually do is I will real quick rename this thing to a text file real fast, just to make sure I don't have a stray line at the end. Save it, and let's see how good this guy did. Want to see if you're getting your money's worth here at Northwestern. Okay, so let's go and open up this thing, KAGLLE, and let's see, make a submission. And let's see, let me log out and log in as DWedding. Log in as DWedding. And make a submission. Can you guys still see me? I think I'm running on borrowed time here.
Yep, we're still
with you.
Okay, great. I'm not sure if I think I'm about to lose internet connection. So let's see how good this thing did. Where's Don1, guys? Help me out. Here it is.
Left.
Okay, and then let's say sync session model. Okay, so let's see how this guy did. There I am. I'm and look at this, guys. Look. 14.1. What was my prediction based on the code I have? It's not too
14.1.
bad. I think that. Yep, there it is. And this is only on 5% of the data. When I open this up to the entire code, then this thing will move around a little bit. But this is probably, I would bet money that this model here will be approximately 14.1 plus or minus when I'm done. So anyways, we've taken this code from beginning to end. It's not a good model by any stretch of the imagination, but there it is. Now, do we have any questions, comments, thoughts, anything?
No, this was helpful. Thank you.
This is a very mild and subdued class. I was.
I'll probably have a lot more questions when I start diving into it more.
Okay. Yeah, you guys, let me give you one little piece of friendly advice. If you haven't started the homework, you're already behind. This thing is not something that lends itself to waiting to the last minute. Hey, Brian, help me out. Tell these guys to start early.
It's always a good idea to start as early as possible, and if you finish, then you can start on the bonus assignment.
The bonus assignment's kind of fun.
Yeah, thanks for that. I was actually focused on the bonus assignments first because they were short and sweet, but I'll flip it around.
Yeah, well, no. You were smart to do the early ones, but now you should be diving into the homework.
The R² one is really good to do before you start this, so you can get an idea. A lot of times we'll have students worried that their R score is really, really low, and so that one helps people see that, hey, a good model can have a low R score anyways. But then the other one, I forget what it's the insurance one, right? This first 3 weeks. That one will be it'll be big like this, but you could get both of them done but you want to get this one done first.
Yeah, this one's worth a lot more points. And you guys, Raymond and Brian have been my TAs for about 4 years now, and they've both graduated, and I don't even know why they hang around with me. I love that they do, but I gotta believe this is a lot of work for them. But they are really smart, and they are some classes work them like rented mules. Other classes don't even know they exist, but they are an amazing resource. Use your TAs, guys. Ask them questions. They'll give you help on advice on modeling techniques, SAS code. Brian gives financial advice. All sorts of stuff. So use your TAs, guys. So anyways, I got nothing else on this end, and my phone is about to die, and I think I'm going to bet money that in any second I'm going to lose connection here on the internet. So I'm going to stop sharing in about 1 second. But any final questions before we go? Uh-oh. Did I lose everyone?
No, nothing
No,
here.
I'm still here. No questions.
Okay. Okay. Okay, guys, I'm going to turn off the recordings then. Okay. Good night, everybody.
Good night.
Thank you.
Good night.
Good night, everybody. Bye-bye.